The Creative College project is aimed at providing world-class education for 1,700 students between the ages of 3 and 18, who represent over 40 nationalities. The project is located in Doha, Qatar. Doha is characterized by a hot desert climate with a long summer from May to September. The annual sunshine hour in Doha is approximately 3,500 hours. According to the psychometric charts of Doha climate, several main strategies to achieve internal thermal comfort are decided. Our basic idea is to put large glazing area to the north where there are essentially no passive solar needs while applying controllable shading devices on the south side to minimize the solar gain.
Our primary goal was not only to deliver a building that fulfills brief requirements, but also to provide a unique design that will make the Creative College a worldwide recognized at the first view. Although innovative in design, our building utilizes a traditional design process. This process begins with an initial concept variations. We wanted to encourage students to interact with each other, and therefore we rejected the idea of scattered layout design. Instead, we opted for developing the integrated design, paying attention to social, economic, and environmental aspects. We developed our model to maximize passive provision throughout the building design. Firstly, the shape and orientation were driven by the goal of having the regularly occupied spaces of the building to be 100% daylit and naturally ventilated. Secondly, we kept to the traditional architectural methods of Doha, establishing semi-open courtyards on the north that will be covered with greenery and provide students with a place for gathering and interaction. Thirdly, to create a design that reflects the growth of the students from primary to secondary school, we implemented the stairs as a part of our building, which gives the students opportunity to move around the courtyards, gathering areas, going from one level to another.
We simplify our building envelope to maximize its performance, and to reduce cost, we use modular type of construction. Most of the construction parts are simplified and made prefabricated in same sizes. The thermally broken modular skylight units are supplied factory assembled, and this allows ensuring not only of zero defect fitting but also reduced installation time on site. Our intentions are not only to prioritize an environment in which students will grow academically. We introduce communication through our design that encourages interactive and inspiring environment, providing great social experience through gatherings. By implementing passive design strategies, including building orientation, facade glazing ratios, and passive cooling, we aim for decreasing energy consumption and carbon emissions of the building.
Internal areas and communications are organized to encourage the same principles as exterior design, providing hierarchy from bottom to the top with shared activities all around the building. We support the students to interact with each other. The ground floor consists of primary school and shared activities, while the first and the second floor consist of secondary education and shared activities together. East, south, and west facade are covered with brisolates and a particular ratio of glazing depending on the requirements of the indoor space.
In order to control solar gains and reduce total cooling load of the building, shading strategies were employed. Extruded floor slabs on each subsequent floor on south facade create overhangs, which act as horizontal shading. Based on the sun path in Doha, 2-meter overhangs were designed to block sunlight from high-altitude sun in the afternoon, prevent heat gains, keeping the south facade shaded and the building cooler. Vertical blades applied on south, east, and west facades block heat and blinding light do not enter the building, still retaining visual contact with the external environment. Position of blades differs on each facade due to different angle of sunlight. They are operable and change position according to the sun orientation during the day. Combined solar shading strategies reduce heat gains by 15% compared to basic design of the building, which excluded the shading devices. According to the daylight analysis of the typical classroom located on the building perimeter on south, the average daylight factor inside the room is 6.2, with minimum daylight factor of 5 on the working plane. Night purge ventilation is the circulation of night cool air from openings into the interior spaces to cool down the inside thermal mass when the building is not occupied. In order to save material and reduce the weight of the building, we decided to use phase change materials as light thermal mass. Night purge ventilation combined with phase change material can result in an almost 50% reduction in cooling energy of air conditioning system.
According to the analysis, the annual energy consumption of our building is 92 kWh per meter square. which is significantly lower than the benchmark of education use building in Qatar. The largest portion of energy consumption comes from the cooling usage, which is related to the heat gain and the cooling system of the building. Thereby, our future target is to improve the energy efficiency and meanwhile apply several renewable technologies in the building.